The mold that created this Haribo gummy bear no longer exists. It was not made from steel, it was not made from plastic, it was pressed into a tray of loose. The mold is gone. The factory keeps the stamp. It keeps the recipe. But the exact cavity that formed this bear is already gone, and the ingredient responsible for that famous elastic chew is not sugar. So how does Haribo produce millions of nearly identical bears using molds that disappear after every batch? The illusion. At industrial scale, Haribo sells one of the simplest images in the candy aisle, a smiling bear, bright fruit colors, a product associated with childhood for more than a century. Hans Riegel founded the company in Bonn in 1920. 2 years later, he introduced the dancing bear, the ancestor of the modern gold bear. Haribo comes from Hans Riegel in Bonn, but the modern product is not built around nostalgia. It is built around repeatability. The factory has to reproduce the same shape, the same shine, and the same resistance in every bite, millions of times. The bear looks simple. The system behind it is not. What creates the chew? On the US Goldbears label, the main ingredients include glucose syrup, sugar, gelatin, and dextrose. Sugar. Glucose syrup helps control crystallization and keeps the candy from becoming a grainy block. But the familiar resistance, that moment when the bear pushes back before it breaks, comes largely from gelatin. Gelatin is a protein made from collagen. When it is mixed with water and allowed to set, its protein strands form a flexible network. That network traps moisture and gives the candy its elastic structure. The exact source and formulation can vary by product and market, which is why the local ingredient label matters. The Chew Protein Network. Designing the bear. Before a new gummy shape reaches the production line, it begins as a drawing. That design becomes a three-dimensional model. A prototype is milled, refined, and used to create rows of identical production stamps. This is where the system becomes unusual. The permanent tool is not a tray filled with hollow bear-shaped molds. Solid stamp, yes. Hollow mold, no. Solid stamp, yes. Building the liquid candy. Inside heated stainless steel vessels, sweeteners, water, gelatin, acids, colors, and flavors become a controlled liquid candy mass. The precise commercial formula is proprietary, but the engineering problem is clear. The mixture must remain fluid enough to pass through hundreds of depositing nozzles. At the same time, it must contain enough structure to become a stable bear after drying, and the nozzles cannot deposit it accurately. Too thick. Correct, too thin, and the liquid spreads before the bear can hold its shape. The factory is not simply cooking candy, it is controlling viscosity within a narrow operating window. The cornstarch molds. Hundreds of temporary bears. This is the stage most consumers never imagine. Shallow trays are filled with cornstarch. A machine spreads the powder and levels it into a perfectly flat surface. Hundreds of solid bear shapes press into the starch at the same time. When the board rises, it leaves behind rows of clean cavities. These are the actual molds. Not metal, not silicone. Loose powder shaped by pressure. The trays move beneath depositing nozzles. Each nozzle releases a precise amount of liquid gummy mixture into the cavities in fractions of a second. The starch supports the liquid without rigid walls. It absorbs and manages moisture at the surface. And when the process is finished, the material can return to the production cycle. The factory saves the powder, not the mold. The drying rooms. The shape is formed fast. The texture takes time. When the depositor stops, the bears already have their basic shape, but they are not finished. The filled trays move into controlled drying rooms. This is not simply a cooling stage. Moisture gradually leaves the mixture while the gelatin network develops and strengthens. The bear becomes firm enough to survive removal from the starch. Drying helps determine whether the final candy feels sticky, soft, rubbery, or cleanly chewy. The nozzle creates the outline in seconds. Time creates much of the bite. Inside the drying room, the product appears to be doing nothing. But this is where the structure becomes stable. Destroying the mold. Once the gummies have set, the trays are emptied, the bears are separated from the cornstarch and cleaned. The powder passes through recovery equipment that removes fragments and prepares it for reuse. Then the starch returns to a tray. A blade levels the surface, and the rows of bear-shaped cavities disappear. The production stamp still exists. The bear design still exists. But the molds that created that specific batch have been erased. One batch, then erased. The factory repeats the same geometry without preserving the individual mold. The bear is still not ready. A gummy bear leaving the starch does not yet look like the product in the bag. It can appear dull. Its surface may still carry fine starch residue. The familiar glossy finish is added afterward. The bears move through finishing equipment where their surfaces are cleaned and lightly polished. The U.S. ingredient list includes sunflower oil and beeswax, ingredients associated with the smooth, shiny appearance of the final candy. After polishing, inspection systems check color, shape, and weight. Malformed pieces are removed. Multi-head weighers divide the product into controlled portions. The bags are filled, sealed, and coated for distribution. The bright, polished bear seen in advertising is therefore not what leaves the mold. It is the result of another finishing system. The system. Condition. Stamp. Deposit. Dry. Recover. Using powder instead of a permanent mold may sound primitive. At industrial scale, it is the opposite. The same starch handling system can produce bears, rings, worms, fruit shapes, and hundreds of other designs. To change the product, the factory can replace the stamp board and adjust the depositing program. It does not need a warehouse filled with permanent mold trays for every shape. The starch supports soft mixtures. It helps control moisture. It releases the finished candy, and it returns to the line. The mold is disposable as a shape, but reusable as a material. That is the real advantage. Haribo may sell more than 1,000 different products around the world. The visible competitive asset is the brand. The invisible asset is a production system flexible enough to manufacture many shapes using the same circulating material. The bear is the icon. The starch loop is the machine behind the icon. What the product really is. So the next time you open a bag of Goldbears, remember what you are actually holding. A shape that began as a drawing. A texture created by a gelatin protein network. A liquid mixture deposited into loose cornstarch. A cavity used for one production cycle and then erased. The product is real candy. The simplicity is the illusion. The bear looks as though it came from one permanent, perfect mold. In reality, the factory rebuilds that mold from powder again and again. Millions of identical products are produced through a system in which the individual mold is never preserved. And for consumers avoiding animal-derived gelatin, the lesson is simple. Read the exact product label. Different gummy products can use different gelling systems. One small bear, one temporary mold, one industrial loop most customers never see. Made Mass reveals the industrial systems hidden inside familiar products. Subscribe for the next factory. And watch next to see how Ferrero builds billions of nearly identical chocolates around one fragile wafer shell.